Okay, good afternoon, good day. I hope there are some people will be watching me. This is the first part of some live presentations where we would like to introduce our group of the product which Swiss Rotors manufacture. And for the day today, there will be some information about the Counterflow, some principle of the Counterflow, how it is built, how it works, and what is the difference between Counterflow, plate cross heat exchanger, and usually, which everybody knows, cross plate heat exchangers. Advantages against this cross flow plate heat exchangers. So let's start. Some just overview and base information about this Counterflow. So you can see the picture on the right side. And this is the difference between cross flow, so the middle part of the exchanger. The rest is more or less the same. And now, what it gives to us? Simple working principle. The exchanger core, airflow pass to each other in the nearby channels. And the channels are closed by double folding plates all together in order to secure tightness. And then this Counterflow direction of the air exhaust and supply give us the highest possible efficiency. We can have also, instead of aluminum core plates, we can have also the high impact polystyrene core plates. And the heat is transferred when the partial airstream flows crossly and partial airstream flow counter through the channels. And then the fresh air and the exhaust air is completely separated and giving the parameters through the aluminum plates. So some short video, how does it work and how it is built. So you can observe this Counterflow. So there are external parts and then internal core. And this is how the air goes through. And then the channels, which are parallelly in the different location. So just basic. Now, why we have this high efficiency, which can come up to 95%? Because in the middle part, where there is still quite high temperature difference between supply and exhaust, this is quite a big part of the surface exchange. So you see this middle part, which is allowing the Counterflow on the supply and the exhaust air, showing these differences. And then about how we build it and then how we test it later. So this is quite, I mean, the plate design was tested maybe, I think, 8 months until we found the final shape of the middle part and also the external part. And then this allows us to give the highest possible efficiency with the reasonable pressure drop of the air. And this is for the aluminum, because aluminum is not easy to be formed. But there could be also polymer core, which is much easier to be folded, and then we can reach higher exchange surface and then we can, of course, lower increase the distance between the plates. That means we can have a lower pressure drop with the high efficiency. So this allows, this high impact polystyrene core plates. And then due to the fact that we are doing the double folding and then it is done everything by the robots, we can ensure very high tightness, and there is very, very small leakage, internal leakage, almost nothing. The shape, as I mentioned earlier, was especially tested a few months to reach the best possible. So usually we can have in the middle part, which is, the shape is like a waves in the triangle shapes, and then external triangle parts, which give some embossing through it, and then keep also the distance between the plates. And then the left bottom corner, you see this fully double folded plates. So we are starting to bend it double 180 degrees twice. So it's much stronger compared to the other ones, which are not doing everything, double folded. So some information. The shape, as I mentioned, is quite unique, especially designed for the higher efficiency and lower pressure drop. The plate double folding for ultra low leakage and resistance at high pressure differential. Thanks to this double folded, it can stand higher differential pressure. And also these two plates, as I mentioned earlier, double folded to 2 times 180 degrees, is giving also higher mechanical strength. So it's not so fragile. The edges, those edges are not so fragile like the other ones. Some information about the test. Each plate heat exchanger, before we release it and then start to pack, must go through the internal leakage test. This is introduced by the norm EN 308 and also some guidance from the Eurovent. So we are following those guidance, and 100% of the exchangers I tested. So we cannot print label with the quality stamp mark if it's not passed through this test. And the tolerance, this is generally speaking, everybody can get this norm and read what is going on with this internal leakage test. But generally speaking, via the nominal flow through the exchanger, there cannot be higher than 0.5% of the leakage. And we have a special design, as on the pictures on the left side and the right side, you can see that there is a suction and pumping small fans, and we are checking the difference between one side and the other side. Some operation limits of the heat exchangers. The maximum recommended, of course, we can have a bit higher, but recommended is 300 pascals, because earlier, with the higher pressure drops, you will need to have a higher capacity fans. That means higher power input. And recommended airspeed, air velocity is up to 3 meters per second. The best is around 2 meters per second. And the maximum differential pressure for the aluminum plate exchanger is 800 pascals, and the same for polymer. And the temperature limit is from minus 40 degrees up to plus 70 degrees for the aluminum plates, and minus 20 to plus 50 degrees for polymer plates. And where we can use those counterflow plate cross heat exchangers. Usually this is very popular here in Europe for the suspended units when we do not have enough space above the false ceiling. Because this exchanger is, the height of the exchangers is lower than the cross plate, but it's a bit longer. So it's not a problem to have a bit longer units, but we can save a lot of space in the height. But of course, if we properly install those units in the normal standing air handling units, it could be used also in the other one. And the best is for the smaller airflows, but also we can build the whole system for the much higher airflows, but then it is a bit more complicated, some construction to how to install the units. But for that, we have some solutions, which we will announce shortly. Get some pattern because solutions. It will be very easy installation inside the air handling unit. Some differences between the counterflow cross-plate heat exchanger and cross-plate heat exchanger. So on the left side, in the bottom, you see this is the counterflow plate heat exchangers, and we are showing this middle part, which is where we have this counterflow pass of the two streams. On the right side, in the normal, see cross plate heat exchanger, there is no this area. And what are the effects? Of course, in the middle part, there is the highest efficiency. And in these small triangles on the entry on the left side and on the right side, there is much smaller efficiency. So normally it works like the cross plate heat exchangers. And how it is that we have this higher efficiency, you can see in the middle sketch. So in the corner, when there's very short pass, there are the biggest difference of the airstreams between supply and exhaust in the corners. So, but this is very short time when the air go through it. In the middle pass, usually we have the highest possible temperature differences. Why we can have this highest efficiency coming out from these counterflow plate heat exchangers. So once again, the differences and the advantages. We have a better efficiency. The counterflow heat exchangers are more flatter, of course, a bit longer than the crossflow. And this is advantage for some suspended small units. Effectiveness of the counterflow can reach 95%. And the cold corners are removed, so there is no, especially here in cold, climate in Europe, there will be not such a lot the possibility of the freezing inside the heat exchanger. And then we have, of course, smaller dimension. So that means if we have a smaller dimension, we have a smaller mass, and thanks to it, lower cost because there is a less material used. And the crossflow heat exchanger needs to be 1.55 times larger to achieve the same efficiency. And even with that, we cannot reach higher effectiveness than 70%. So I would like to thank you for your time, because I know everybody are busy in those difficult times. So I hope you enjoy. I didn't want to take too much time of you. So, but we are waiting for some questions which you can write. So I am here to reply for some questions. So I will be waiting if somebody will write anything. And if you write, I am able, and I am here for you.